Okay, thanks for the introduction. It's really great to meet you all here. And today I want to talk about HCI stuff and how we can connect the real world into to the computer world. And I guess we can get started right away, right? So before I get started, I want to just mention that if you have any questions or if you have any arguments, feel free to interrupt at any time. I love interruptions, and you can just feel free to chime in at any time. So I guess you are all knowledgeable in HCI, and you all know what a user interface is, right? When you hear the term human computer interaction or user interface, what first comes to mind? What are the things that, yes, smartphone or maybe touchscreen? I'm not really sure what you meant. Maybe one of those two things, right? And anything else? Touchscreen is a good thing. Yes. Users. Yes, that's very, very important. Yes. Anything else? Buttons. Yep. Those are great examples of a human computer interaction or user interface. So here, this is a, yeah, I'm not a really good, I'm not very artistic, but yeah, you can tell there is a user, right? And we have a computer and we are using computers using some sort of a user interface. And that user interface may take different forms. So maybe we can use keyboard to enter some text, right? We can type in some words, or maybe sometimes we can use a computer mouse or a touch screen to control something, right? In this case, we are not just sending those texts, we are sending some coordinates. And when we do that, the computer will do the computing. It will do some computation and then it will give us something visually, or maybe using some speakers, and it can give us some sound. So these are the typical user interfaces that we use. This is how we use computers. And there's a lot of things to study here. But yeah, this is kind of a simple representation of these. And also, these days, we're not just using keyboard and mouse and displays to just work with computers. We also use computers as a medium. And like right now, we are also having Zoom audience here. And they are seeing maybe me, maybe not. And I'm hearing my sound. And also, they're seeing the slides, right? We use computer as a medium to relay some information like the video and audio to that remote person. So yeah, that's cool. That's really good. And we're now at a really interesting time. This is really exciting. Computers used to get input from a user, and those inputs were usually very well defined, like the character input, or maybe it was coordinate input. And sometimes it just relays the information to a different person. But these days, we are seeing a lot of things that are new, like AI systems, artificial intelligence, and they are doing some really interesting things. They're not just taking our input, they're also understanding the world. They're trying to make sense of what is happening in the world. And in the past, pictures were just pictures. This is a picture of my cat, Ducky. It's a little bit dark here, but yeah, she's stretching there. And it was usually just a set of color pixels, RGB pixels. But now with the help of those machine learning models, we can know which is the cat and what is maybe my shirt or the couch. We can know that, and computers can understand that. And not just that, computers also make sense of what is happening there. So yeah, it says that the image shows a playful kitten lying on its back and its stretched legs. There are more information and better understanding of what is actually happening in the real world. And this is really cool because now we can use this machine intelligence to make computers to really work with the real world. So they can be in the same space as us, not just us being like the only operator kind of inputting things for the computers and maybe interpreting the results. So this is cool. Now it has an understanding of the real world. And that's a really exciting time. But there is one problem, which is a lot of these things are happening because we are handling things. So there's the word, there's this computer, and usually us humans are becoming the middle person and putting some things for the computer to understand. And when computers give us some results, we try to understand what the computer is saying, and we execute some things in the real world. But can we make it more integrated? Can we just make the real world and the computers to be maybe better integrated, so that like we are using right, like we are communicating with others, like we are collaborating with other people. They are not just telling us to do things, they can do things for us. They help each other. And sometimes if I need some slices of pizza, if I can ask someone to do that, they can, I think, kindly do that. You don't have to, I already have a slice. But but yeah, things are happening in a more physical way in the real world. Maybe now is the time that the computers can actually do things for us. And how can we do that? So that's the question we at UVA are asking. And I think we tried several different things, but today I want to share two different approaches that we have taken to connect them better. So maybe if you want to connect the physical world with the computer world or the virtual world, maybe we can virtualize the physical things, because those two are very different worlds. We need a way to connect them, and maybe we can physicalize what is happening in the virtual world. And right now it is really, really vague. So I'll just jump right into the examples. So the first one is about virtualizing physical world for fluid remote communication. And here, I want to share this Think Here paper that we presented at CHI this year. And it is about supporting with video meetings to, making video meetings to better support our physical interactions. So I think we all have been here. We are using Zoom or maybe Skype or Teams a lot, right? We use these a lot. These are really essential part of our life right now. And we are not just sharing our faces. We're just not talking. We share screens, and also we share some physical things like these. Maybe we can show some physical prototypes or some toys or maybe some paper or maybe something in the background. Those are becoming an essential piece, not just for project related work, but also they're great conversation starters, right? But using these is not really easy. There are so many different problems. When you are dealing with hardware prototypes, we use hardware prototypes a lot. You get to use Zoom for showing prototypes. And there's also this frustration when you cannot pinpoint a specific location. So if you're seeing a video like this, there's another person there on the other side, and you want to pinpoint this IC. And how you do that? You usually have to say a lot of, not that one, to the left, to the right. And that's a lot of saying, right? It's not very convenient. Pointing or referencing is a big problem. And also, we are not always having meetings in the lab, right? Sometimes we have meetings from home, and our homes are not always organized. At least mine isn't. And we have a virtual background because it's nicer. And that virtual background sometimes happen to also remove our messy prototypes. So there are many issues like this because those Zoom systems are not designed for that. And we wondered, is it just us? Is it just us having these problems? So we conducted a formative study, and we did a survey with 124 Mechanical Turk users. And we asked them, how often do you show physical objects in video meetings? Do you ever do that? And for leisure related or and also for work related meetings, people do share physical objects at least occasionally. More than half of them do share those physical objects in remote meeting. There are many reasons why they do that, but I'll just skip that part. But we also asked how they show objects. And I think it's similar to how we, like in our group, used to share objects. You just have a webcam, on your laptop or on your desktop monitor, and you bring an object to the camera, and that's how you usually show the object. Sometimes you may use a dedicated camera setup that is more fancier, that has the document looking perspective, but almost half of them just hold the object up to the camera. Some just take a picture and share that with others. And yeah, this is how people usually share objects in remote meetings. And they also have challenges when they use those methods to share objects in remote meetings. There are challenges with showing details. Those cameras are not so great at capturing all the details. So if you are showing a research paper, it can be maybe blurry, or it can be maybe too small for the real person to read what is written there. If you're meeting someone else in person, you can just hand it out, hand it over to the next person, and you can just share that nicely. But here in remote meetings, it's really difficult. Perspectives, you are just showing this in front of a camera, and the remote person have no control over what side to look at. So it is really limited if you want to show multiple pages or show different size of an object. Is really, really tough. Remote referencing, like I said earlier, is a problem that people are already having. And framing is also difficult part, because when you are showing something in front of a camera, then you are not seeing the object, right? And you look at the object because you want to see the same side, and you're focusing on this, and that object happens to be outside of the camera field of view, and that's annoying. And there's also problems with privacy, because virtual backgrounds can be obscure the object, but you may not want to turn off the background because of the privacy issues. So there are several challenges of showing physical objects in remote meetings. These are the problems that people are having, and how can we solve them? So if we look at those problems, those details, perspectives, remote referencing, framing, privacy, those problems are there. But if you think about how you share virtual things in remote meetings, they're not really a problem. If you want to share your screen, you can choose just one window to share with someone else. You can show all the details. You can zoom in, out. You can organize windows differently. There are, so when you're dealing with virtual objects, these aren't really problems. Then back to this ugly picture. So I think the problem here is happening because the camera here, or the computer here with the camera, is just hacking everything as a video and audio stream and relaying that to the remote person. And I think that is causing this problem. It has no understanding of what is there. And I think if the computer understands, so that's the picture being sent, if the computer has an understanding of what is around us, then maybe we can make the computer to make all these things into virtual assets, so that we can have all these flexibility and freedom and capabilities of virtual object manipulation in remote meetings. And here's the system that we built to enable that. It is called ThinkShare. And the main idea is to create the main idea is to virtualize physical objects in an ad hoc way, in an instant and real-time way, so that it can be shared across different people. And this is what the system looks like. So here, here's my student Urjan, and she wants to share this game controller with Gwen. And when she wants to do that, she can just use her mouse cursor to just drag and drop this physical object to this object library on the right top corner. Or she can use the right mouse click to make it virtualized. And then from there, it's just a virtual object. So you can do all these different kinds of things in remote meeting that you do with virtual assets. So here we switch the view. This is now from the view from Wen's computer. And Wen can bring this physical object from the object library to her view. And she can, of course, manipulate its size or rotation or position. And she can also bring her own object and make comparisons next to each other. And because it's virtual asset, you can do all different kinds of magic, right? It doesn't have to be a single item. You can make multiple copies of the physical object, and you can make this curtain to be duplicated, and you can have a better looking room. And if you want to discuss something in detail, you can maybe have a more focused sharing view here. Like when you're sharing this sketch, you can bring this physical copy of an object and make it enlarged. And of course, sometimes we use our hand to reference things. So it shouldn't be a picture. It should be a live updated video. And your hand can also be segmented because the model can tell that that's your finger or that's your hand that is interacting with the physical object. So we can crop this from the video and make it enlarged and be updated in real time so that when you're discussing all these details, the remote person can see what is happening in detail. And the object is tracked in real time. So whether you're moving the paper left to right, the focus view will always have this paper stabilized. So we can have all these capabilities of virtual object. Of course, we can also make annotations if you don't like the font of this sketch, or if you want to ask some questions about it. It is all possible because it's a virtual asset. And sometimes we want to show different perspectives. And when you want to do that, if you're meeting in person, the next person can probably just hold it in their hand and rotate themselves. But even in person meetings, if I want to show this to you, and if I want to show different size, then it can be difficult for me to just hand this over to everyone in the room, right? I can rotate it around, but it can be tiring for me, right? Because it's light, but if I were to have something heavier, then it can be a little bit tricky. But we can also make this virtual asset to have this temporal information. So if you want to show different size of this Starbucks coffee bottle, then we can just record different size. And anyone in this meeting room can just have access to all different size. They can just manipulate and inspect in their own way. And of course, you can have this virtual asset to be annotated or mixed with other objects. So if you are seeing this and if you're helping with the debugging, but you need to add more components, then maybe you can just have this LED in your hand and make it virtualized and bring it to the scene so that you can have it on this breadboard, and you can also make some connections by drawing on this virtualized asset here. So after implementing this system, we conducted a user study to understand how people use this system. And we compared this with traditional video meeting system, Zoom. And overall, the participants were very positive about using this system for meetings that involve physical objects. They like that they can use those digital copies, and those digital copies don't have to be held in the hand, and they can have a better view of the visual, the object and the video, and they can have all these playful interactions, like having all these physical objects flying around, and also they like that they have this remote access to digital copies. So if someone has a very cool object in their room, you can steal them or maybe borrow them to decorate your own room temporarily. And also, you can have parallel exploration. So you can have this physical object and the virtual copy of the remote physical object and see them side by side. And they also like that they can maintain the privacy when they're sharing the physical objects, because we can selectively show the show the objects in the video meeting and make other things to be still blurred or covered by the virtual background. And also, there are some other uses that we didn't expect. So for asymmetric tasks, when you are showing something to someone else, when you're explaining things, people like that they can see the same side and still look at their the other person's eye and see the same perspective, maintain the same perspective. So it doesn't have to be you looking at the device and the person like switching those perspective every time. People like that they can have a shared perspective, and also they love that they could help gauge attention of the person, so that you can also know if people are interested in some aspects or some part of the user of the device or the object. So overall, we got many positive feedback from the users, and we think there's a great potential in using ThinkShare system. There are some limitations, and there are some other issues which I think you can find in our paper. But I will move on to the next part for the time being. And this is kind of the opposite direction. It is about physicalizing virtual interaction for accessibility. So this is also a paper that we presented at CHI this year. It is called Take My Hand. And Adil was the leader of this project, and Ashik was also a co-author of this work. And I'll show you that drawing again. So computers are now able to see what is happening in the real world. They can recognize what is in the real world. And also, they can use that information to locate themselves. They can understand which direction they're looking at, what kind of surfaces there are, and also what kind of orientation they are placed at. And they have great potential in making computer systems more immersive. Like augmented reality systems, they can use the cameras to accurately position and locate themselves, so that they can blend those visuals with the real world, so that people can really utilize all these augmented visuals to understand, to better execute their real world tasks. But there's another very interesting aspect, which is, so here I put some text here, but the computer can now sense the environment, and it can do the computation, and it can create those nice visuals blended with the physical world, so that you get this augmented reality view. But it doesn't always have to provide you with this visual augmentation. Maybe you can use other senses, right? The computer can maybe sense the environment and use these capabilities to help people who may maybe benefit from having different sensory channels. So, for example, this great paper is called State Lens, and it was done by Seongkook and his co-authors, and it is about helping blind users to complete tasks with the app guidance. And in this work, they use a mobile device. They can see what is on the screen, and also this also able to see your fingertip location by using this thimble-like device. And this provides this audio feedback, so that when you're operating a touch screen, the system can help you find the right button to press. Yep, I think this is a great use of technology. I think computers can now sense the real world environment better, and maybe they can help people to maybe utilize other senses, other sensory channels to maybe interact with the real world. And that was using audio channel. And there are some other papers. This is actually from University of Maryland. I know you're doing a lot of great accessibility work, so really good. They are using these vibro-tactile actuators to guide the user's hand movement, so that they can also interact with the real world objects and touch screens better. And these are really awesome use of technology. I love that. But here, if you look at how it is happening, it is basically computers sensing the environment, and they're using not the visual output, but different output channels like the audio output or haptic output to help people navigate or complete real world tasks better. But there is one problem that really struck us, which is here computers are sensing the environment and they're giving the feedback, but it is not actually changing anything. It's the user who needs to interpret the signal, who needs to understand what is happening, and then that person needs to control their hand to actually make something done, get something done, right? And this is not an easy task. This interpretation and manipulation task is very heavy in terms of the cognitive load. And we thought, what if we can make it simpler? What if we can just like computers to automatically move something so that the user doesn't have to interpret all the time and doesn't have to control this hand movement all the time. And of course, the user will, instead of manipulating their hand by themselves, they can maybe get this kind of haptic feedback from that movement. And maybe they can be used for them to understand what is happening. And instead of them having to interpret all different signals, they can just let computers do the work. So that's what we wanted to try. And of course, there are several different ways of actuating the user's hand. If we want to make this happen, we need an actuator that can move something. And there are some different robotic interfaces. There can be some other electrical muscle stimulation methods or some mechanical actuation methods. And I think there are really great methods out there. But in this work, we prototyped this finger rover device, which is a small robotic device that can move the user's finger around on a 2D plane. And if you have this device, you can let computers move your hand. And the workflow is like this. The user can tell the computer about their intent. So in this example, the person can say, where are my headphones? And the computer can understand where the headphone is, where the other obstacles are on this table. And they can make some past planning, right? Those are simple things that computers can do. And then it can control this robot to follow that path so that users can move their hand right next to the headphone. And the computer can't make the person to grab the headphones, but it can let the user know using this audio guidance that your headphone is right in front of your hand. And we thought about different applications, different ways of different uses of this technology. It can be used for locating objects. So this is a demo of locating objects. The robot will just move around all these obstacles, and it will say the cup is right in front of you, and you can just grab it. And of course, it can also be used for operating touch screens. So it will move the robot, and you don't have to think where your hand is moving. It will just say your hand is right on the button, so you can just click it, and it does that. And sometimes you may want to get some remote support. So if you want to have a Zoom support from IKEA, I'm not sure they do that, but if you want to assemble something, and if you don't have this visual channel, then it can be difficult for you to communicate what exactly you need to pick, where exactly you need to move something to a different place. And we implemented a system that the remote person can remotely control this robot's movement so that they can remotely guide someone else's hand as if they're just holding someone's hand and moving to a different place. And of course, if you are learning some concepts, knowing the shapes or geometry can be a very important piece, especially if you're a younger student who needs to learn about the geometry or mathematical concepts, like different shapes or different graphs. It can be tough. And maybe those shapes can be controlled or rendered by the computer, and your hand can maybe just follow this trajectory, and you can sense make of a shape. So to understand if it really works and what kind of effect it has, we conducted a user study with 7 visually impaired and blind participants, and we use those 4 different scenarios to understand what they feel about it. And also we measure the completion time to see if it is effective at reducing the time for completing the tasks. So for the locating object task, we compared between the spatial guidance method and traditional audio guidance method. And the participants could complete the task significantly faster with the spatial guidance technique, the automated spatial guidance technique compared to the audio guidance technique. So yeah, it was faster, and participants felt that it is a little bit safer because they know that the robot is kind of avoiding the obstacles, and it is not just you blindly following those audio feedback and not being able to know what is along the way. And they also found that it's more efficient. And also for operating touchscreen, spatial guidance was faster than the audio guidance. And people like that. It also gives you that haptic feedback so that you know where to stop or where it stopped. You can know that kind of tangible feeling. And it is also very simple, which they liked. For assembling objects, actually spatial guidance was slower in terms of the average. There was no statistically significant differences, but this happened because in this case, we found that participants, they utilize their both hands to remember the locations of some known objects. And that really reduced the time for test completion for the audio guidance, which was not really possible with the spatial guidance because your hand uses this this finger over robot. But they still found this to be very, very interesting because it is easier for them to pick things up when they are in a jangled mess. And yeah, sometimes bubble instructions are not really clear, and this helped them to navigate the way better. And for the shape sense making, we didn't compare this with the audio feedback because it was not really feasible for them for us to explain shapes verbally. But we showed we rendered triangles, squares, and rhombus, and in general, the participants could understand and recognize those shapes. They could recognize them as the same shape, or sometimes they recognize them as similar shapes. For example, for the square, some participants said it was trapezoid, some said it was hexagon, and for the rhombus, people said that it feels more like a rectangle or off-the-angle square, and so on. So there were a lot of benefits and good things about this interface. We found that there are some benefits of using this method. It was faster at operating touch screens and locating objects, and it was easier and less fatiguing to just follow the robot than interpreting the signal audio feedback all the time. But it is not without any issues. There were some issues with performance when you are using that remote assistance scenario. You cannot utilize both hands, and maybe we can use better actuators for this. But there is one very important thing that we wanted to discuss in the paper, which is about the user agency. Here, I think this is the most critical part. This idea of automated hand-based spatial guidance. It can be promising. You're offloading your task to this robot or this computer, and you're doing less. But it may also mean that you're just relying on this computer, and you may just need to trust this computer to do the right thing. And there can be some possible risks, and it is something that we shouldn't really overlook. In this work, we really paid special attention to build this device so that it cannot overload the user's hand force. So if the user doesn't want to follow that movement of the robot, then they can just maybe exert some excessive force or just leave their finger off the robot. But still, there are so many questions remaining in this one. The user may relax their agency, but it can be dangerous if the system gets compromised, and there can be some serious risks. So I think this automated hand-based guidance can be promising technique, but safety must be really carefully considered when designing this type of systems. And in our study, we also asked users about what they feel about their agency or their control over this robot. In our study, all users, they unanimously agreed that they felt completely in control over this finger over device. And they said they could stop following the guidance at any point by simply lifting their fingers. So it's just the characteristics of our device, but it doesn't mean that the system cannot create any dangerous situations, because if the user use this system over a long period of time, they may build trust, and they may really believe that the system is always doing the good thing. So I think in the future, we really need to think about how we can transparently communicate what is happening, even though the system is having some agency, having some control over what is happening, how the user is moving their hand. So this is how we can physicalize the virtual things to help people with visual impairments and blindness. So here we are again. So we studied and tried various methods to better bridge the gaps between the real world and the virtual world. And there are some promising results. There are some maybe some concerns or limitations. But I think it can be really interesting to see what we can achieve by utilizing all these artificial intelligence. They can have a better understanding of the real world or our intentions, and how we can interface things nicely so that we can really utilize the computing power in our everyday lives and our daily tasks. And that's what I wanted to share. And there's one really important thing that we learned over the course of these projects, which is that the capabilities and limitations of these two words are really different. So maybe just replicating one of these words to a different and applying to a different word may not be the best solution. We try to do that for our projects at first, but for example, for ThinkShare project, in the real world, we have really good vision, right? We can see things in very clear resolution, almost like ultimate infinite resolution. We have 3D vision and all these nice things. We are losing this because it's a virtual world. But there are some things that are possible because it's a virtual world. We don't have to be limited and constrained by the laws of physics. We can let things fly. We can let things to be duplicated, right? There are so many cool things we can do with the virtual world and virtualization of the physical things. And about the Take My Hand project, if you are working with someone else, you have that trust. You can believe that person. And you have the tactile sense, you have this large shared and rich tactile communication and versatility. But you cannot have someone to always be with you. But with the virtualization, you can always have your computer or your phone to always be with you. You can be always ready with that person. And yeah, that can be a great benefit of using this virtualization. And I think it's just a matter of how we choose and how we enable the utilization of those benefits of each word to maximize the utility of these AI systems. So that is all I prepared for today. And here are the collaborators and my students who did the work for all these cool projects. And if you want to learn more about our projects, these are my PhD students. You can go to our group webpage. It is called Ultimate User Interface Group. And you can see what's happening there. So that is all I prepared. Thanks for your attention. And I'd love to take any questions.